employ Euler's formula to show that the following four trigonometry identities, that is, sine or cosine, the sum or difference of two angles. Proof. Euler's formula is this. Euler's formula is this. I times theta equal cosine theta plus I sine theta. And theta is an arbitrary real number. And I is defined as square root minus 1. Proof. Euler's formula is e to the theta I theta equal cosine theta plus I sine theta. I is defined as square root minus 1. But in engineering society, they use j equal square root minus 1. But in mathematics or physics, they use notation I to stand for imaginary unit. From this formula, we apply to two angles. Therefore, we have e to the I alpha plus beta we can simplify e to the I bracket alpha plus beta equal to I alpha e to the I beta. Now, we can apply on both sides with Euler's formula. So on the left side, we have this one. We can apply this formula. So I have cosine alpha plus beta plus I sine alpha plus beta. So I just substitute alpha plus beta into theta. So on the right, I have this e to the I alpha equal cosine alpha plus I sine alpha. So this is here. Now, e to the I beta equal bracket cosine beta plus I sine beta. So this term is here. Now, the right side I can perform further. I have cosine alpha, cosine beta plus I cosine alpha sine beta plus I sine alpha cosine beta minus sine alpha sine beta. Then next step, I combine the real part together and the imaginary part together. So this part is real part and this part is also real part. So I write down cosine alpha cosine beta minus sine alpha sine beta plus I times sine alpha cosine beta plus cosine alpha sine beta. So here I have real part and the imaginary part. Therefore, I compare this. On the left side, I have a real part. This real part, and here's also real part. And here's imaginary part and imaginary part. Therefore, I conclude that cosine alpha plus beta equal to cosine alpha cosine beta minus sine alpha sine beta. Now, this is the one formula I need to prove. I call this formula equation 1. Equation 1. And if I compare the imaginary part, this term and this term, I have sine alpha plus beta equal sine alpha cosine beta plus cosine alpha sine beta. So this is the other formula I need to prove. And this equation I call equation 2. Also, we remember that, so recall that sine is an odd function. Minus theta equal minus sine theta And the cosine is even function. Minus theta equal cosine theta. So sine is odd function, and cosine is even function. Therefore, from equation 1, I have this. I have cosine alpha minus beta equal, I treat this formula as alpha plus minus beta. So I use this formula. I just change my new beta is minus beta. So I have here is cosine alpha cosine minus beta minus here sine alpha sine minus beta. And then this is the even function and this is the odd function. So therefore I have a new formula as this. A new formula cosine alpha minus beta equal cosine alpha cosine beta, because cosine beta minus beta of cosine equal to cosine beta, and this minus sign will cancel out with this minus sign. So plus sine alpha sine beta. Now this is the other formula. This is another formula. From equation 2, from this equation, I have sine alpha minus beta equal sine alpha cosine minus beta plus cosine alpha sine minus beta. Again, I use the property of sine cosine, so I get sine alpha minus beta equal to sine alpha cosine beta and minus cosine alpha sine beta. So now I just proved all 4 formulas. This is the same as in the beginning.